works this time. Today we're switching into 4.7. We made a jump. We just finished 4.4. We glossed over 4.5 in terms of the graphs of functions, right? When we talked about the function of sine and the function of cosine and tangent. Today what we're talking about is inverse functions, specifically inverse trig functions, right? Because that is what we've been working on is trigonometry. We are going to focus first on the inverse sine function, and then we'll talk a little bit about cosine and I don't even know if we get into tangent today. We get the basic rundown of it, but the inverse sine function. Sine usually has an E on it. We abbreviate sine by SIN instead of SINE. It's not much of an abbreviation. It almost seems not worth the while. Yeah, we'll shorten it for you. We'll take one letter off. So the inverse sine function is defined by, let's see, we'll call it definition. Y equals arc sine. Arc sine, when we write it like this, just means inverse sine of x. We often write it also like y equals sine to the -1 x. Both mean the same thing. Either way you write it, it just means the inverse sine of x. But what it means is it says the inverse function, the inverse sine function is defined by y equals arc sine of x if and only if and only if. In mathematics, if and only if is usually abbreviated like this. But I didn't figure you guys would know what that meant. If and only if sine of y equals x, where -1 is less than or equal to x, which is less than or equal to 1, and -pi over 2 is less than or equal to y, less than or equal to pi over 2. What does all this mean? You were wondering, you were thinking? Well, here's the thing. When we are looking for inverses of functions, I don't know if you remember back to inverses of functions, but there were rules for inverses of functions, and they had to meet certain criteria. And that criteria is that they had to be what we called 1-to-1, which meant they had to pass this horizontal line test, right? So if we look at the graph of the function of sine, what did we have? Pi over 2, pi, 3 pi over 2, 2 pi, right? So if I have, say, 0 here, pi over 2 here, pi, 3 pi over 2, 2 pi, right? And if you remember when we graphed sine, we used that unit circle, right? We used whatever y was at the unit circle. So at 0, I have my unit circle here, right? Here at 0, my point was 1, 0. Here my point at pi over 2 is 0, 1. Here my point at pi is -1, 0. And here my point at 3 pi over 2 was 0, -1. And sine was our y values, and everything went between 1 and -1, right? You kind of remember that from the graph? Everything had that between 1 and -1. And we refer to that in the definition. Notice that everything here is going to be between 1 and -1. Everything here is going to be between pi over 2, pi, 3 pi over 2. And when we graph these, like if I have this graph extended, let's put that back in blue. If I have this graph extended over here, right, all the way out to, say, -pi, right? If this is -pi, this is -pi over 2. What you would notice is that we have this graph that kind of goes like, this would go down to 1, and it would come up to 0, and then it would come back down at pi, something like that, right? This would only go up to 1. But you get the picture. You get the idea of that wavy thing. Now, if you look at this, and I tried to draw a horizontal line between it, if I tried to pass a horizontal line between anywhere on here, notice that it would not pass that test, right? I've got it crossing here, I've got it crossing here, and I've got it crossing here, right? So technically, the entire graph of sine, if we keep going, can't have an inverse because it doesn't pass the horizontal line test. But if we look at it on an interval, and this is the interval that we want to look at it on right here, if I were to drop, if I were doing it just from here, so -pi over 2 to positive pi over 2, if you look at that section, it does pass the horizontal line test, right? If I draw a line just through any part of this section of the graph, it does have an inverse. And that's the intervals that we're talking about working on, right? Is this inverse sine function is only true between the interval of -pi over 2 and pi over 2, right? And so we have these parameters on it. Now, yeah, it can only go up to 1 or down to 1, but it gives us a good feel of how these things work and how we can make them work. Because the truth is sine is something that goes on forever. We can keep turning that wheel, right? 4 pi is just 2 times around the circle. Another 2 times around the circle is 6 pi. Another 2 times around the circle is 8 pi. And it's the same thing, and it's just going further and further in this direction, but it's the same pattern repeating. So this interval will always work, and it will always have an inverse, if that makes any sense at all. And when we're evaluating these functions, it's not nearly as complex as trying to explain them. Looky there, I've got all that math on there. I did not clear my screen. So, oh look, I even have a, well, I had it. That would have been handy a minute ago to know that that was there. But it actually is pretty handy to have right now. So let's erase it so you can see it. I don't think I need it to be quite that large. Just want to make it a little smaller. Well, I can only do it if I make the screen smaller. So when we're evaluating those functions, so say I want to evaluate inverse sine functions. Remember when we say evaluating, we're talking about finding a solution, right? When we evaluate something, we want to find a solution. So evaluating inverse sine functions. If I have say we'll go with A, arc sine of -1/2. And let's put B up here too. Sine inverse sine of radical 3/2. And let's go with sine of 2. Right? Whether I write it as arc sine or sine with that little -1, they both mean the same thing. Remember, they're just asking for the inverse sine. When we're looking at a problem like this, if you see, it says here, arc sine of y equals arc sine of x, if and only if sine of y equals x. What does that mean? It means that we're inverting this problem. What I have to do now is find what sine of x equals, right? And what I know is that when we're solving for A, I go, okay, well, I have arc sine of -1/2. And I go, okay, well, where does sine equal -1/2? Now remember that sine is our y value, right? And so we know that sine equals 1/2 at that 30-degree mark. Where does it equal -1/2? Well, it equals -1/2 right here, right? But it also equals -1/2 right here, does it not? But that's not so important as far as this goes. We just need to know that it is that 30-degree, that reference angle, right, which is pi/6. I know that at pi/6, sine equals 1/2. So at sine of -pi/6, we get -1/2, right? Does that make some sense? I don't want to move on because I feel like my explanation on that might not have been the clearest. It does? Okay. So if sine of -pi/6 equals -1/2, we can say that arc sine, or the inverse sine of -1/2 equals -pi/6. And that's what it means by inverse, right? This is our solution. So here we have arc sine. It's still an arc sine. It's still the inverse sine function of radical 3/2. So where does pi equal, where does sine equal radical 3 over 2? Right here at 60 degrees, or pi over 3. So we can say that sine of pi over 3 equals radical 3 over 2, right? Notice this is a positive radical 3 over 2. So I can just say the inverse sine of radical 3 over 2 equals pi over 3. So as long as you have a unit circle in front of you, not super complicated stuff, right? It's just remembering to switch first, find the sign, and then the answers flip. Sine over sine, inverse sine of 2, though, does not have a solution. Any idea why it doesn't have a solution? If you look back at our parameters on this, it says that everything has to fall between negative pi over 2 and pi over 2. And if you look at that, even on this, right, negative pi over 2 would be here. Pi over 2 would be here, right? Now, think about what 2 is on the wheel, right? We know that from here to here is pi, right? 3.1415926, whatever, right? So between here and here, this is going to be about 1.5. This is going to be about negative 1.5. 2 does not fall in the parameters of our interval that we're working with, right? 2 would be somewhere in here. And we know that we can only use this shaded area right here, right? Anything on these two sides is good, right? But anything on the other side doesn't work. So it doesn't meet our interval requirement, and therefore sine inverse of the inverse sine of 2 has no solution. So you have to keep in mind the parameters on this. Most of them, where they'll try and get you is with, if it's a solid number, you're like, okay, is that number between pi over 2 and negative pi over 2? And if it's not, there can't be a solution. So if I were to look at something like arc sine of 1, that would fall into that solution, right? Because if I look at when I see arc sine of 1, I go, okay, well, where is y1? Well, y is 1 up here at pi over 2, right? So I would go, okay, well, sine of 1 equals pi over 2. Therefore, sine of pi, sorry, even I'm messing it up now. Sine of pi over 2 equals 1. right? Because pi over 2 is where y is 1. So we can say that arc sine of 1 equals pi over 2. So all of your other functions are going to work similarly, right? But they're going to have different parameters. So when we want to define all of the trig functions, well, the three. Definition of trig functions. The function itself would be something like y equals arc sine if and only if sine of y equals x, right? That's the one we just did, sine of y equals x. And then we had a domain, right? And our domain was between -1. Sorry, that's supposed to be y. No, that's supposed to be x. Cosine would be y. And 1, right? And it's got a range of -pi/2 to pi/2, right? Our function y equals arc cosine if and only if cosine of y equals x. And now our parameters, here they're still going to be -1, but it's going to now be the y in here instead of the x is 1. And this one has to lie between 0 and pi. I think I wrote that wrong. I feel like that should be x right here. And then our last one is tangent. Y equals arc tan if and only if tangent of y equals x. And our parameters on this one, -infinity. Well, I guess I don't need it can't equal -infinity. It would just be less than -infinity. So we've got -infinity to infinity. And then your parameters on the range would be -pi/2 to pi/2. So we'll work on more functions like that. On Friday, we'll get into the other functions, but we're going to stick to just the sine function for your assignment today. Like I said, once we get back on, what is it, Monday, we will do the other part of this section. I'm not going to give you more than like 5 problems on today's homework. It's only going to be arc sine functions. They're fairly simple. When we get back on Friday, I'll give you a few more dealing with cosine and with tangent. And then the end of next week, you'll get your test. Any questions about that? I highly recommend keeping your unit circle in front of you when you're doing the homework. But talking to myself again.